We introduced the ModQuad, a novel flying modular robotic structure that is able to self-assemble in mid-air and fly cooperatively. The multiple self-assembly robots have been shown in the robotics literature, but none of them can assemble in mid-air. In contrast to assembling on the ground or on water, docking modules in mid-air offers a relevant advantage by enabling a more rapid assembly process. The module is propelled by a platform within a lightweight cuboid frame, which allows it to attach to other modules by matching their vertical faces. Docking in midair requires an accurate alignment of the vertical faces of the modules. Modules can misalign due to motion errors or external perturbations. In our approach, one flying structure waits in a hovering action and the other structure performs the docking action. This reduces the motion errors and disturbances from the hovering structure so that the other structure can precisely align and dock. Once two or more robots are connected, we need to change the flight controller to allow multiple robots to cooperate instead of fighting with one another. In this paper, we focus on two of the main actions that the team of modular robots can perform. These actions are docking structures in midair and cooperative flying. The structure is composed of agile flying modules that can easily navigate in cluttered environments. We present a stable modular attitude controller to allow a set of attached modules to cooperatively fly. Our controller generates the required moments that minimize motor saturation. This is because connected robots generate what is essentially a new vehicle with a larger inertia tensor and different dynamics. This system is redundant, but it is necessary that the structure be coordinated and that the method of doing so is generic in order to form arbitrary configurations.